All right. So next up, we talk about the SmartPy. We talk about what is a smart contract, right? So we are done explaining the basics of blockchain and all of that, and we've gone into Tezos and that. So let's talk about smart contract, because that's what we are here to talk about, right? So a smart contract is a piece of code that is deployed onto a blockchain platform. It is usually made up of code and a data structure that can be manipulated by the code. Since it is deployed to the blockchain, it is publicly transparent and immutable. So let me just explain what I read. It's a piece of code. Yeah, like a piece of code, right? That is deployed onto the blockchain platform, and that is why it is called a smart contract. So when you have code that is deployed onto a blockchain platform, we call it smart contract. That's the best explanation I've heard so far. And of course it's made up of code and then some sort of data structure that is attached to this code. Think of it as like the storage for the code, and then you can store certain stuff there. So let me just try to illustrate something. So let's say this is a smart contract, right? This whole thing is a smart contract. Oh no. So this whole thing is a smart contract, right? And then you can divide it into two and say, well, we have the code somewhere here, and then we have the storage, right? So this is where we store data is stored, right, in the smart contract. Okay, so keep that in mind. And then this smart contract finds its software on the blockchain, right? So this smart contract, this is code and storage and displays on the blockchain, right? So Bitcoin has smart contracts, Ethereum has smart contracts, and of course Tezos also has smart contracts. And so we are going to look today at writing smart contract in Tezos using a specific Python library called the SmartPy library, right? So another thing is that it's deployed onto the blockchain, and we know that blockchain is kind of a public thing. It's a public data it's a public database, right? So anyone can go and view what is on the blockchain. So when you deploy code when you deploy a smart contract onto the blockchain, anyone can go onto the blockchain and read the code of the smart contract and also see the data associated with it. So for instance, let me just go to this place, this so something I haven't mentioned yet is what is called block explorers. So what's a block explorer, right? So as I mentioned, that a blockchain is essentially a public database. Anyone can query this database and have access to all the data on the blockchain. Just that you can't change it, but you can query it. You can't change it without the right authorization or something, but you can definitely query it, right? So a block explorer is just like basically a website that someone has written querying a blockchain, right? So in fact, if you are paranoid enough and you think that you don't believe what other people have done, you can go and write your own code to explore the blockchain, pull down the data, and then display it, right? So for Tezos, there's this very interesting block explorer that we're going to look at right now, and specifically for smart contracts and all of that. So yeah, so it's called Better Core Dev. So Better Core Dev, let me just change this to here. it's a Tezos Block Explorer. So let's pick a random smart contract. We pick a random smart contract, and what can we see? You can see here we have the storage, right? So here you'll be able to see like what has been stored in the smart contract so far, and then we have the code, right? And this code is written in what we call Michelson, because on the Tezos blockchain, the main code that runs on the Tezos blockchain is Michelson, right? So what you're about to learn, that's SmartPy. Once you write SmartPy, it compiles into Michelson, right? So the advantage of this is that it doesn't compile into some sort of byte code, zeros and ones that humans can read. So the Tezos developers, they chose like this Michelson because this is readable by humans. I mean, if you understand the Michelson kind of stuff, you can actually write code directly in Michelson. The point is that looking at this is not that convenient. You agree with me, right? And so if you look here, you can see it defines something. The parameter also defines the storage, and then it comes to define what the code. And Michelson is a stack-based language and all of that. I mean, the first time I heard about it, I said no, and I heard, oh right, you can write in Python, and then it will compile here. And I said, all right, there's no need to know what Michelson is, right? So basically, when you write your code conveniently in Python, you get a Michelson code, right? So SmartPy will compile that nice Python to some interesting Michelson code that you can use for your stuff, right? And maybe probably over here you can interact with the whatever is going on here and that. And I mean, it's interesting looking at what is here. Anyway. Oh wow. Right. Okay, let's not go overboard. So there are a lot of block explorers. In fact, Bitcoin has block explorers, Ethereum has block explorers, and they are just looking on the data, like on the smart. They're just looking on the blockchain, and they are querying the data on the blockchain, and they are kind of like displaying it on the internet so everyone can see. And if you don't believe them, you can go yourself, and then go and look at the Tezos or like there's particular API for that blockchain, and then you can also write your own stuff to look at your own things. But I mean, man, how would you do that? So that's what a smart contract is, just a code, right? Just a code and the storage, nothing more, nothing less. Compared to like what like a server, the code you write and put on your server, right? So you write some code and you put it on your server, and this code runs on your server, and it has access to some database like MySQL or Postgres or something. It's the same thing, right? Same kind of concept. It's just that in this case, this code is on the blockchain, and it has access to its own data structure that you have to define yourself, right? So then in that case, well, what are the interesting properties of smart contract? Why would you write something? Why would you write a smart contract instead of maybe normal code, like, and put it on your server and let it run? I mean, and the point is that it has certain properties that I would like to point at some of them, and these properties makes it possible, or makes it like really interesting, or it makes certain application very, very, very like possible, right? So first, the smart contracts are publicly transparent since they are deployed to the blockchain. Anyone with access to the blockchain can see the code and data associated with it, right? So let's go back to an example of usage of blockchain where people are pushing this kind of voting thing, right? So we want to have some kind of software that facilitates voting, right, or elections, right? And before blockchain and all of that, anything, that software would run on a certain server, and not everyone has access to that server, so not everyone can see the code on that server or the code that's currently running, right? But with blockchain, as I showed you here, right, I can use this block explorer to see the code that is running, right? And this is the code, and actually, if I can't understand this, I can hire someone to read it and say, oh, okay. So imagine like maybe a party when we are having these elections, we have different parties, trying to win the election and all of that, and everybody's kind of aggressive here. So they can hire their own expert who can read and understand what code is here, and they can verify that indeed the code is doing what it's doing, right? And this is more secure. This is more, makes you feel more safer, and everybody feels more like fair, because they know like what code is running, and all of that. So it's public, and that alone is an advantage that traditional servers don't have, because you need access to the server before you can view the source code, right? So you can't see your PHP code or your Python Django code from the browser. You have to get access to the server, and not everyone is willing to do that. So, yeah, smart contracts are immutable, right? So once they are deployed to the blockchain, they cannot be altered. So this kind of code here is what is going to be there forever. Nothing can be changed. If we want to change the rules here, then we have to update our smart contract code and then create a new address, right? So we update our smart contract and deploy a new contract, and this contract will be in a different will have a different address, right? Because one thing you should notice that on the blockchain, everything has an address, right? So for instance, for this particular contract, this is the address of this particular contract, although it's not fully stated here. So the point is that this code or this contract and whatever is here does not change. It's there forever and ever. Amen. Alright? Doesn't change. Doesn't. And also, one interesting thing is that it offers free data replication, right? Because of the way the blockchain works, and since the smart contract is stored on the blockchain and the data associated with the smart contract is stored on the blockchain, I mean, all the nodes on the blockchain have that smart contract and also the data associated with it. Now what happens? It means that if there are 1,000 nodes on the blockchain, your data is stored on 1,000 different nodes. So can you imagine that this is not, for normal cloud services and all of that, maybe they can store your data on 2 or 3 servers or some backup servers and all of that. But you have 1,000 servers for free without doing anything, right? Not necessarily for free, but there are some costs associated. But still, the replication is crazy, right? So you can store something there and it will be there forever and ever, right? So these are the interesting properties of smart contracts that, if you think about it, yeah, it's not surprising that people are making a lot of noise about it, because this has not been possible till now, right? So now let's dive into what is SmartPy. So SmartPy is a Python library for writing smart contracts that can be deployed on the Tezos blockchain platform. The original smart contract language for Tezos is Michelson, as I explained, right? With this example here. So let me just pick another one. So this is Michelson, right? Sorry. This is Michelson, okay? So I just click here to see another kind of pick a random smart contract, and this is the address of that particular smart contract, and this is the code associated with this smart contract, right? This code here is Michelson, and as I've already said, we don't write Michelson directly. I mean, of course you can write it directly, and there are people, if it's a language, I mean, it can be written directly, but really so if you know Python, then you don't have to worry about Michelson. You can just write in SmartPy and then to compile to Michelson. So SmartPy allows you to write your code in Python and then compile your Python code to Michelson. Alright, so that's it. So then let's write before. So we are just going to, the goal is that I'm just going to do some interesting example with you, which is a simple land registry smart contract example, right? So if you've heard, one of the interesting applications of smart contract is land registry, right? So we are going to learn how to create a smart contract on the Tezos platform with SmartPy to build a simple decentralized land registry application. It should be able to assign the geographical rectangles to real-world users. So in this use case, we are saying, oh man, we just want to build a smart contract and say that, look, tell me like the 4 points of your land, and I'll store these 4 points, right, on the smart contract, and then I'll assign it to your address, right? So that means it belongs to you. By address, I mean your address on the blockchain, right? Because I mentioned that on the blockchain, everyone has 3 things. That is their public key, their private key, and then their public key hash, right? So basically, when you hear someone saying your address, your blockchain address, you are talking about the public key hash, right? Yeah. So we'll get to see all of this, right, once we start with the SmartPy. So we just want to say, hey, give me 4 points on the earth, prove that is yours, right? So because the way land registry works, it for now we are just writing a simple application where those who have already registered their land can register their land, can then now submit their land to our smart contract. You understand? So this is how it will happen. We are going to have people called, and you should be able to assign geographical rectangles to real-world users. All this info is stored publicly on the smart contract. Users should be able to transfer parts of their land to other users, right? So now once you're able to you prove to others the land belongs to you, right, by showing us the certificate and all of that. You show us the land certificate and everything, then we will store it on our smart contract for you, right, and assign it to your address, right, your address. Once you assign this to your address, that means since it's your address, you are the only one who have access to the private key, and so only you can decide, can have access to that, right? So we will get into that soon. So you prove to us that, oh, the land belongs to me by showing us your already registered land that you've registered with the land registry. So we are not focusing on any country or something. We just said it doesn't matter which part of the world you are in, right? You just show us proof that this land is yours. We prove it, and then we digitize the land on the smart contract for you. Once that is done, you can sell parts of the land, right? Users will transfer part of their land to other users. So let's go deep into what we're saying. So we are going to on this application, we are going to have a special users called the registrars. So the registrars are those users that we have authorized to be able to add land onto the smart contract. So if you want to add your land onto our smart contract, you go to the registrars, right, and the registrars will verify your document, and then after that they will add it to the smart contract for you, right? And then so these in practice could be corporations and land agencies in various countries. Now when a landowner is ready to put their land on our smart contract, they must contact a registrar and prove to them that they actually own the land. Yes. Once this is done, the registrar assigns the reticular coordinates of the land to the public key of the public key hash of the owners, right? So you, as I said, you give them your public key hash in the document. They will prove that indeed the land is yours, and then they will assign the land to your public key hash. And then what happens next? So we assume that the land can be represented as 4 points of longitude and latitude, right? So this point is actually longitude and latitude, right? So XY, right? For now, let's do something simple like that. XY, X1, Y1, whatever. So longitude, latitude, 4 points, and then we have the land, right? Now, landowners can be able to split their land. So let's say you say this is your land, right? and we've proved that indeed this is your land. Now the land will be splitted into meter squares, right? And then you can assign prices, the price per meter square, right? So let's say that the whole land could cost maybe so on the smart contract, once we digitize the land on the smart contract for you, that means that although it's land, now it has been digitized, so you can break it down, right? And you sell the pieces. So that means this piece can be owned by someone else, and this piece can be owned by someone else, right? Yeah. So land owners can now sell pieces of land. The smallest piece is a square meter. Land owners must list the prices per smallest unit, right? So for example, all right, so let's now dive into the code, okay? And it's through this code that I'm going to explain to you, like the SmartPy and everything, because I just wanted this to be very practical.